Hey everyone, and welcome back to my channel. In this video we will examine how to use GetX state management when creating our cross-platform mobile application for Android and iOS using Flutter. So in the project overview you can observe a simple user interface. In the app bar there is a text that reads today with the current date displayed below it. In the body section there are three distinct cards. The first card displays the user location, which is obtained through a straightforward API call using the IP API service. In the second card, we retrieve the temperature of that location using the OpenWeatherMap API. I will provide more information about those API services later. And lastly, the third card provides a weather-based recommendation to the user. For example, if the temperature is 17 degrees Celsius in New Jersey, the text displayed might be, you should savor the weather, it's lovely. And this text dynamically adjusts based on the temperature. If you are having a good time watching the video, don't forget to click the like button and subscribe. Let's not waste any more time and jump right into it. First, let me explain the API services we will use in the project. We are going to use a service called IP API to find out where a user is. This service looks at the user's IP address, but it might not always be completely accurate because it depends on where the internet provider is located. To put it simply, it helps us figure out where the user is without asking for permission to access their location. And here is how it works with a French IP address as an example. And secondly, to get information about the temperature in the user's location, we are going to use OpenWeatherMap API. Make sure to create an account to get a free API key. We will need it to make a HTTP request. And here is a part of the data we will get as a response from the API. And these are the specific pieces of information we are interested in. Now that we have a good understanding of the project's background, let's begin and start developing our app. To begin, let's create a brand new Flutter project and add the necessary dependencies. To do this, open the pubspec.yaml file and add these dependencies. GetX, it's our state management package. It's basically help us to make a reactive UI and structure, organize our app's code, making it easily scalable while reducing the boilerplate. The HTTP package is a useful tool for making network requests and working with web-based data on your mobile app. It allows your Flutter app to communicate with remote servers, fetch data from APIs, and send data to servers. The Google Fonts package is a Flutter package that makes it easy to use Google Fonts in your Flutter application. The loading animation widget is a package that provides attractive loading animations for implementing loading actions in our app. Intel package gives you everything you need to make your app work for people from different places. It helps with translating messages, handling plurals and genders, formatting dates and numbers, and dealing with text that goes both left and right. The Lottie package in Flutter is a powerful tool that allows you to integrate and display rich and high-quality animations in your mobile app. These animations are created in Adobe After Effects and exported as a JSON file. Next, let's include an assets folder in the project and configure our Lottie animations to be loaded in the pubspec file for later usage by clicking the download button to obtain all the required dependencies. Once you encounter an exit code 0 in the debug console, proceed to launch the Flutter demo app to verify that everything is functioning as expected. Next, let's create some folders to give structure to our project. In the data folder, we will include the location and weather classes, each with their own from.json method for populating the class instances through API calls. The module folder will house our home UI, home controller, and binding, all of which will be implemented using GetX. The repository folder is responsible for managing the data and acting as an intermediary between the data sources, as an example from a database, web API, or local storage. In this project, we will have a weather repository file that will fetch the user's location and weather by sending a request to the server. And once it receives the data, it will send it to the controller for display in the UI. The widgets folder is responsible for organizing and storing reusable widgets. You will have a clearer understanding of this as we delve into the coding process. Go into main.dart file and start by deleting the whole content. This file is the one we are using to run our app. The core function to start the Flutter app is the run app function that will create our widget tree. Let's come up with a title for our app. For instance, weather app with GetX sounds good. Afterward, we should hide the debug banner and provide an empty scaffold to the home parameter of the material app to create an empty app. By default, Flutter uses the Material App root widget, but the getX package requires to change it into getMaterial_app to take advantage of package's features. In the getPages parameter of the getMaterial_app, it's important to specify your screen, controller, and binding. This will contain all the pages of our app. Each page widget will be wrapped within a getPage object. Homepage is the UI for the root page, also named as /. And home binding contains all the classes the homepage needs to work correctly. As an example, the controller, the repositories, and etc. And we will get into these later. Now that we have completed the main.dart file, let's create a new homepage widget using the STList shortcut. Typically, the main widget for a new page is a scaffold, and we will include some UI elements with mock data to display content. Let's come back to the main.dart file and import the homepage. Next, we should include the homebinding.dart file, which we discussed earlier. This class should extend bindings, and we need to override the dependencies function. In short, this is how we inject dependencies in the get package. My primary focus in this project isn't on creating an outstanding UI. So for now, we will keep it simple. We will create a basic app bar with a column as a title. Inside the column, we will have a text widget displaying today and the current date below it. In order to display the current time accurately, we must create a function utilizing the Intel package within Dart. This function, known as formatDate, requires a date input and transforms it into a specific string format containing details such as the day of the week, date, month, and the year. The format pattern that we are using to specify how to date should be formatted is EEEDMMM. Why? So, what do we mean by this format? This represents the full weekday name. As an example, Thursday. This represents the day of the month as a single digit. This represents the full month name. As an example, November. And lastly, this represents the year as a numeric value. Let's return to the code and perform a hot restart to observe how the function is working. We are implementing the sizebox.expand widget to maximize the utilization of space on our home page. As its child, we have incorporated a column to arrange items vertically in a cascading manner. Using the Lottie widget along with its asset property within a specified sized card widget using Sizebox, we will load our animation. You can customize the Lottie widget properties like adjusting its height, width, and more. To explore and find your preferred setting. Next, we are implementing the Rich Text widget, which offers the functionality to apply various text styles within a single text widget. Our primary objective in using this widget is to highlight the value retrieved from the server, such as the city name or the temperature. At this point, notice the text string is displayed using a lighter font weight, whereas the subtext string is presented in a bolder text style. To enhance clarity on the screen, we will add padding to our widget. Additionally, we will employ main axis alignment that space evenly within the column widget to evenly distribute space between its children. Moreover, for the card widget, we are giving margin properties and border radius to create a circular rounded edge on the border and some space horizontally and vertically. And subsequently, we will position all the widget within the main column to be centered on the screen. Next, as you saw in the project overview, we need other 3 cards on the home page. Therefore, I am extracting this widget as a reusable widget and passing the dynamic parameter to it. So everywhere we need this widget, just call the reusable widget and we pass the class parameter to it. Following that, it's essential to transfer the class parameter to the widget parameter at the specific point where its utilization is required. Presently, if you take a look, the initial entry will be our location displayed using Lottie anime, and the basic string that reads your location is, followed by the name of the city where we currently reside. At the moment, I have temporarily inserted to do. However, our plan is to replace this placeholder by retrieving the information from an API response and populating it here. Similarly, the remaining 2 elements also feature their own Lottie animation at the top. One displays the text the temperature is for the temperature section, while the other showcases the text you should for the advice section. We plan to manually implement the content for the advice section at the later stage. At the moment, this user interface is fantastic for the app. Let's proceed by creating a file named weather item within the widget folder. We will place our previously crafted weather item widget in this file to maintain cleaner code. This serves as our reusable weather item widget. From now on, simply by calling this widget, you can effortlessly create weather items throughout your application. Next, we will need to import the essential packages for the newly created file, including Google Fonts and Lottie. Additionally, to utilize the weather item in the home page, we need to import the newly created file as well. We could extend getX controller to grab the features offered by get library. Inside the controller, we will define two functions. The first one, get current location, will handle the logic for fetching the current city. And the second function, get temperature for current location, will focus on retrieving the temperature for the current city. To accomplish these objectives, we will require two data models, one for storing city information and another for weather details. Firstly, let's explore how to retrieve current city information. We will utilize the endpoint ipapi.com/json. Response from the request to URL will resemble the following. Thus, we need to create a Dart class that corresponds to information. The main purpose of the from_JSON function is to transform the JSON data received from the HTTP request into a Dart object that can be utilized within our application. Okay, after that, let's create a repository responsible for making the API call and organizing the data for our controller. This repository will be named weather repository. The get current location function is asynchronous, denoted by the future it returns. This future contains either location patiently waits for the response to arrive asynchronously before moving forward. Upon receiving some response body into a map type of string and dynamic using JSON decode. Then it suppositionally employs a location data.from_JSON function to transform the JSON data into a structured location data object. Upon successful conversion, it prints a success message that includes the obtained JSON data and returns the location data. However, if the response status code is not 200, it logs an error message and returns the location data. This location data might be null if the conversion from JSON to location data didn't occur successfully. Excellent. Now let's recall the bind, which is crucial for gathering all the necessary elements for the UI to function smoothly. Our home page specifically requires the weather repository and the home controller. To make this happen, we must create instances of these two objects within the dependencies function. This get.lazyput is a function that generates an object instance only when it's needed. For instance, when we invoke its methods, if the object hasn't been created yet, a new one will be generated, and if the object to our controller and utilize the get current location function within it. First thing first, we create a variable named location data of type RxN with a generate type of location data. The RxN object is an observable, but with a nullable type. In this scenario, since we won't know the location data until we make the request, it's initially set it to null. And to make sure the user sees their region and country, we make a getter variable called address. This variable grabs the needed info from the location data and gives it back as a string. We will use this in the home UI. And in the onInit function, which is called as soon as the home controller is created, we invoke the getCurrentLocation function to obtain location data. Within the getCurrentLocation function, firstly, we create a variable called location of nullable type location data, which is the model we created earlier. We then call the getCurrentLocation. As its value is filled, we assign it to our RxN location data variable. If the request is successful, we have the location data in this variable. If not, it remains null. Later, in the home UI, we will display different widgets depending on whether it's null or contain real data. Now what we need to do is update our UI with the value we retrieved. We will grab an instance of this controller in the home page and watch for changes on location data to show the user's current address. Please remember that the underscore prefix on the variable's name makes it private, meaning it's only accessible within this class. After that, to ensure our UI reacts to the changes in our controller, we need to enclose the body with an OBX widget. This will notify an update body's content whenever an observable value changes. Now we can include the controller's address variable in the text widget. Since address is linked to an Rx observable, the OBX wrapper higher up in the widget tree will be triggered when its value changes. They cannot be constant anymore. Then perform a hot restart of the app to see the result. Great! Our application formed while the app fetches the real data from the server. To do this, let's check if we have location data. If the location optimized this animation using the styles from the loading animation widget package that we added earlier. Now if the data loading widget appears at the center of the screen. This lets us know that the app is fetching data from the server. Once the data is fetched, we can see the real-time weather information displayed on the weather card that we have developed earlier. Alright, awesome. So far everything's been going smoothly. Now in the next step, we want to get the temperature of the user's location and display it on the home screen. To do this, we will use the OpenWeatherMap API. Just a heads up, temperature. But for our project, we only need the temperature. Of course, you can access and use other data like humidity, pressure, and so on to make the app more interesting and complete. Oh, Okay, first thing first, let's create a Dart model that matches the request to the server. Great, now that we have the API keys sorted out, we can continue with the coding. We will add a new function called getWeather4Location into our weather repository. This function will handle the request to the API. We will start by creating a weather data object called weather. This object will hold the data we receive from the server, similar to how we handled location data before. And to send a request to Open Weather Map, we need certain parameters, as I mentioned earlier. We will create a variable called params and include the necessary parameters for the request, such as lat, LAN, CD, and app ID, where we will pass our API key. For the first three parameters, we can extract them from the location data object that we received earlier. We will use the latitude and longitude from the location data object for the lat and LAN parameters. And for the CD parameter, we will pass the region name. After setting up the parameters, we will send an HTTP request to the server using the provided URL along with the parameters and then await the response. Similar to our previous function, we will check if the response status code is 200. If it is, we will decode the JSON response and apply it to our .from.json function to populate the weather data. We will return this weather data. If any errors happen during this process, we will return the weather data with null values inside. Alright, let's return to the controller to complete the remaining tasks and finalize this feature. First, similar to how do we get parameters from it. So first we check if the location data has been filled with some real data, and it's not until the weather data value gets filled. Then let's create a variable of type rxn weather data info text to fetch some text recommendation based on the current weather temperature at the user's location. Let's go ahead and create this function. As you can see, it takes a nullable integer type called temperature because it will determine the recommendation based on this variable. Of course, this recommendation should depend on multiple felicities. Okay, let's focus only on temperature. We will have four scenarios. If the temperature is null, indicating that the weather data hasn't been fetched yet, we show the string unknown. If the temperature is equal to or greater than 0, indicating cold weather, we display the text "make sure to dress in warm clothes. It's freezing out there." And if the temperature is less than or equal, if the temperature is greater than 15, indicating hot weather, we show "savor the weather, it's lovely." And of course, since the observable info text hasn't been created yet, we have these errors. So let's create it to resolve these errors. The info text is a type of observable RX string. Think of it like a tracker for location data. The OBX widget needs to keep an eye on changes in this variable, so we start with a placeholder value of 3 dots at the starting point. Remember our getter variable called address that we made before? It helps us display the location's region name and country in our app, not directly in the UI. But these getters help us show their right information neatly. After setting up those getters, it's important to ensure that in the onInit function, we await the getCurrentLocation function first before calling the getTemperature for current location. This is because getting a temperature for the current location requires the location data to be available. So before running this function, we need to make sure we have the location data ready. To achieve this, we simply add to await statement before these two functions in the onInit function. This ensures that these tasks are completed in the right order. Finally, let's integrate these new variables, temperature and info text, into our UI. And for the temperature, I am adding a degrees C string next to the controller we injected into the home screen earlier. Great. And one final adjustment we need to make is to the condition we set up earlier for showing the loading spinner. Initially, we used the location data variable value for this task. However, now we should change it to the weather data value because weather data is the last parameter fetched from the server and it depends on the location data. Actually, if we keep using the location data for this purpose, there is a chance we will see a null string in the temperature weather card for a few seconds, which isn't ideal. So let's update the condition, things working just like we wanted. You will see the location, the temperature in our city, and a little suggestion based on the weather. Easy, right? Now let's switch up my location in the max setting to check out another scenario we planned earlier for the recommendation text. Great, location changed, the weather and recommendation text have also switched up accordingly. Okay, let me offer some ideas to enhance the project even further. You can incorporate error handling when calling the API. For instance, if the user doesn't have a network connection, you can display a snack bar to inform them, prompting them to ensure they are connected to the internet for the app to work properly. Additionally, you can include an image that updates based on the current weather condition. This would add a visually dynamic element to the app, allowing user to see the representation of the sky status alongside the weather information. That's a wrap for today, and I hope you have enjoyed enjoyed watching and have learned a lot. And thank you for tuning in, and I hope this has made your Flutter journey smoother. You can access the complete project source code on my GitHub. I've included the link in the video description. Also, don't forget to follow me on Instagram for more amazing Flutter content. But wait, there is some exciting news. If you have developed an app based on this tutorial or improved upon it, share it on Instagram and tag me in your post. I'll be there to support you and help you to get more views. This support comes directly from me to you. And finally, don't forget to smash that subscribe button and give this video a big thumbs up. Share it with your friends, Flow developers, and anyone who might find it helpful. If you have any suggestion for future tutorials or question about this one, feel free to drop them in the comment section below. Until next time, take care and catch you later. Bye.